In this video, we're going to talk about OR probabilities. And this isn't really a mathematical term. Just means that we're talking about the probability of something or something else. So as a beginning example, I want to take a look at this table of data about time spent shopping each week. So we've got an income of people and how long they spent shopping. And we want to find the probability that a random person that we select from this sample either makes more than $60,000 or shops 2 hours or less. So we're looking at two different categories here. We've got those people who shop 0 to 2 hours and those people who make more than 60,000. Now the OR probability, an OR event, means that it could be one or the other. So these 192 people, for example, even though they shop 10 hours, because they make above $60,000, they will count for this event, this compound event that we're looking at. Same with this 176, same with this 128, same, and of course the total there would be 496, so we don't want to double count that. So all of these people in the boxes have make more than $60,000, and so they would qualify. At the same time, anyone who shops 0 to 2 hours a week would also qualify, so that would be 144 and 272. So everybody in these boxes would be people who either make more than 60,000 or shop 2 hours or less. So if we're computing our probability, we could just take all of these numbers and then divide by the total. So these are all the people who qualify for this event, and the total in this case, there were 1,600 people. So we could divide by 1,600, this would give us our probability. There's another way to think of this as well. If we looked at these total columns, so there were a total of 496 people who made 60,000 or more, and there were a total of 544 people who shopped 0 to 2 hours. So if we took each of those separately, we could have the probabilities of each of these separate events. And this would be the probability that the person makes more than 60,000, and then the probability that the person shops 2 hours or less separately. Now, if you actually compute this out, you'll see that these numbers are not the same, because we have a problem here. The 544 and 496, even though all these people qualify, we've double counted this 128 people, because these people were in both categories, both the income and the shopping categories. If we do these two probabilities added together, we have to then subtract the 128. Because this is double counted. Now if you compute these out, these will both come out to be the same. So the probability here comes out to be 0.489 if we round to 3 decimal places. So you can use either of these methods as adding the two totals and then taking out the overlap, or just counting up the people individually. I personally prefer the first method, but the thing you have to be careful with is that when you have or events like this, oftentimes there are people or things or events that occur in both categories, and you have to make sure that you're not counting those twice. Another way to think about this visually is to think about a Venn diagram. So if we're finding the probability of event A or event B, typically there will be some amount of events or people or whatever the case may be that fall into both categories. So what we just looked at before is that we could take the probability of A and the probability of B, but if we just do that, we're going to be double counting this shaded area in the middle. So if you took all of circle A here and then all of circle B, that shaded area would get counted twice. So we then have to subtract that shaded area. This is the probability of A and B. Sometimes you'll see this written as A and then this sort of upside down U, B. This means intersection. So we can compute it that way, or we can just make sure that whatever the numbers are in this little overlap, we're not going to count those twice. So that's really what you have to be working on when you do the OR probabilities, is don't double count anything, right? Only count everything once. To go along with this, we have a definition. If we have two events, A and B, we say that those events are disjoint if they can't occur at the same time. So disjoint basically means no overlap, right? So in our Venn diagram picture, we've got event A, we've got event B, and there's nothing overlapping in between. So for example, if I'm looking at students at Red Rocks, I want to see if I select a student at random, what's the probability that we find a student who takes classes online or a student who takes accounting. So these are two different events, and I want to say, are they disjoint? Or in other words, can they both happen or not? Well, in this case, a student who takes a class online could take accounting, not necessarily, but these are not disjoint. Because students could do both, even though some might do just one or the other, or neither. Another example of two events, we've got the event that a student selected is enrolled in 12 credits, or a student selected is enrolled in 6 credits or less. Now, a student can't be enrolled in 12 credits and at the same time be enrolled in 6 credits or less. So these would be considered disjoint events. And the important thing about disjoint events is that there is no overlap. So if we have the probability that a student is enrolled in 12 credits and the probability that a student is enrolled in 6 credits or less, we could just add those together for the OR probability without worrying about double counting. So in our picture here, right, where we had to subtract off the overlap, if your events are disjoint, there just is no overlap. Okay, to finish up, we have some data here from a clinic. 1,019 people were given a blood test for HIV, and we have a table here that indicates how many people either had HIV, did not have HIV, and then whether they tested positive or tested negative for the virus. So what we want to compute here is to find the probability that a patient selected at random either tests positive for HIV or has HIV. So we've got that OR probability there. That's all for this video. See you next time.